Okay, hello everybody. Welcome to FOSDEM 2016. We are in room 100. In a few minutes, or just in half a minute maybe, we'll hear you talk what the code reviews in Microsoft and as well as the projects have in common. We'll hear Alberto Baccelli. He's working as a professor at the Delta University of Technology. He's researching there. Well, and I think let's begin. Thank you very much.
Thank you very much. Hello everybody, I hope you don't mind to get a bit closer to you. I'm very excited to be here. That's a picture I took back in 2009 when I was in the audience, as you are now. And I really love being at FOSDEM. So for me it's super exciting to be here and talk to you about what I'm doing, my research, and things that I hope you will find very interesting. So just to give you a bit of background about myself. I'm Italian, as you can probably guess from my accent. I studied in Bologna, where I did bachelor and master, and I have quite a few friends here that we meet together at FOSDEM every year. And then I spent 1 year in Brussels here, where I saw FOSDEM for the first time, back in 2007. I worked as a software developer after my master's for 1 year in Italy, the biggest Italian supercalculus center. Then I started a PhD in software engineering, because being a software engineer, I realized how difficult it is to write good software. So I said, maybe I can help developers become more productive. During that period, I had the chance to visit Microsoft Research twice. And part of what I'm telling you today comes from the experience I had there. And currently, I'm assistant professor at the University of Technology in the Netherlands. And there, besides teaching, I do research on software engineering, how to help developers become more productive. Okay, and that's it about myself. So today I'm going to talk to you about modern code review. And this small comic tells you everything about what modern code reviews are. So they are informal. There is no meeting that you have to attend with many people together at the same time. They are tool-based and they are synchronous. These are the three main characteristics of modern code review as opposed to code inspections. So especially the most interesting thing, which makes being informal and synchronous possible, are the tools that are used for code reviews. You may know, for example, Merit. Many of you probably also know GitHub pull requests. They are becoming more and more popular every day. There are some proprietary tools like Atlassian, and there is also an internal tool developed at Microsoft called Microsoft Code Flow. I use this as an example. The idea is that all the tools, they work basically the same. They offer the same functionalities. So you have some code that you have changed and you want other people to review this code. You prepare a package, either to a pull request or creating a package separate from the versioning system, as it happens here. And then you send this code to some reviewers, right? And then they have the chance to look at the changes using a normal textual div to see whether the changes that you created are right. And then they can, for example, put some comments and say this is good, this is bad, you should change this, and so on and so forth. This, for example, you can have some logs of what's going on. And then the thing is that you can have multiple iterations. So you can submit some code for review. Reviewers can say, well, you should change these things, and you iterate over this code until either the reviewers decide to not merge the code that you are proposing, or to merge it with the code base. Okay, so I would like this small talk to be pretty much interactive. So I would kindly ask you to take 3 minutes, go on this website, and fill the survey I prepared for you. And I promise we are going to see the results during the talk to see what you say about it. if for any strange reason this link doesn't work, that's the Google form link that I work. When you're done, please raise your hand, so I'm sure I'm not putting too much time on this. I see my answers flowing in, so 1 more minute. I think should. Okay, shall I go on? Okay, so I've seen that almost 80 of you replied, so thank you very much. That's amazing. Okay, so I told you that I'm doing research on modern code review. So why are taxpayers paying me to do this? Well, I think there are two very important reasons why one should do research on code reviews. Nowadays, especially with the popularity of GitHub and pull requests, code reviews are becoming more and more popular, especially also in open source software systems. They've been popular with Linux and everything, but nowadays that it's so easy to create pull requests, each project can easily have code reviews. And what happens when something becomes popular? Well, people start saying things about how something should be done in the right way, why it is useful, so on and so forth. But unfortunately, there is not much research that tells us exactly what code reviews are good for, and why and how you should do them. The second point is that it seems there are many glitches with modern code reviews, and it's very important to understand them, to understand what the challenges are, what the outcome is, to see what can be improved. So these are the main two reasons why it's important, in my opinion, to care about code reviews. So to focus on these two things, the first thing that we thought about doing was trying to see what happens when real developers, professional developers, do code reviews. Because for literature, what you have is literature about code inspections, something that was done around in the 80s, 90s, in which you had very formal meetings in which you would stop coding for like 3 days, send the code to the other team members, the team members would check it, and then you meet in a meeting and go line by line, one line by one line to find all the errors in that code, and once everybody's happy, then this can be merged. But this took forever, and not many companies are doing this nowadays. But what we know about code inspections is that it engages developers and others in a formal process that usually detects more defects in the product than does machine testing. So the question that one can ask is, can we trust these results also on modern code review that have the idea of inspecting code but are done in a completely different way? This is one of the things we want to test before going on and write things about code reviews. So how can you empirically test what's going on? Well, one of the places in which you want to be if you do empirical research in software engineering is Microsoft Research. I know it's a strange place to say this thing, but Microsoft Research is very open about the studies they do. So this is one of the research centers that really publishes in academic venues the results of what they're doing. And these people are in tight connection with Microsoft product groups. So you can really talk, discuss, ask things to developers, analyze their data to ask the empirical question you want to answer. So I went to Microsoft Research in summer 2013, and I studied together with a researcher there, Christian Berg, what happens, what are the practices of modern code review at Microsoft, so that we could understand them better and see what's really working and what should be improved. How did we do it? Microsoft is very interesting as a place to do this kind of studies because it's all in the same place, but you have very, very different groups doing completely different things. So for example, you don't expect people in SQL Server to use the same IDE that people use while developing the Windows code or other applications. They have completely different ways of creating their products. But they have one thing in common, they all use the code flow review tool. So all these different products and many others, they use this tool for doing code reviews. So this means that we can filter out problems due to different tools. They are all using the same tool. If we see some results that are different from group to group, they are not due to the fact that they use different tools. This is a very interesting opportunity to do research about this. So what did we do? Well, when you want to do this kind of studies where you really don't know where you want to go, you do something called qualitative research, and you start without hypotheses and you say, okay, I want to see what people tell me about this phenomenon. So we said, okay, now we want to go and observe developers while they're doing code reviews, and afterwards interview them and ask questions about what they think are the challenges and so on. So in this process, we started, that's the first part of the study, we started observing 18 developers. So with different roles that signed at least 50 reviews in the previous 3 months. So the idea was that the CodeFlow tools has an analytics background that could tell us whenever a new code review request was created. Once that was created, we would write to that developer and ask if they could go and observe that developer in action while doing the code review. So the Microsoft campus is really huge. So I spend a lot of time on these shuttle connects. Every time a developer would say, yes, please come and see me doing my code review, I would jump on these shuttles and go to the building. They have around 100 buildings. It's really huge. Okay. And then we got some findings from these interviews and observations. And we wanted to see, the most important thing we wanted to see was, first of all, why do they do code reviews? We got some results from the interviews, but of course we wanted to have more people telling us what they think about it. So we also sent a survey to managers, asking them, why do you ask your developers to do code reviews? And these are all the reasons why they ask them to do so. And these are exactly the same reasons that you found on the survey that you just did. So to find alternative solutions, to improve the code, to find errors, so on and so forth. Okay, so in this first phase, we got the possible reasons. Then we extended this to developers. We sent a survey to around 2,000 developers, almost half of them replied, asking them exactly what you did, to rank these motivations for doing code reviews by importance according to their opinion. And these are the results. So, why do Microsoft developers do code reviews? The first reason to do that for them is to find defects. 72 managers and 384 developers said that this is the main reason they do code reviews. Okay? Let's see what you think is that. Okay, I have almost 200 responses. This is awesome. If you get some point. Okay. So I'm happy that you find code reviews important. And if you do them frequently. Okay, so why? I would immediately look at the top 3 reviews. I will put this data available. So according to your results, it seems that the top reason is to improve the code quality. Not much finding defects, which is also, I would say, the second reason at this point, but it's more about improving code quality rather than finding defects. That's interesting. It's a bit different from what Microsoft developers said. And I guess most of you are working on open source, so well, let's see what the results are. That's very interesting. And you'll see why. Okay. So, according to Microsoft developers, the main reason to do code reviews is finding defects. The main reason for you is to improve code quality. Now, these are things we asked them. Like, what do you think? Would you trust them? No, I never trust developers. Regardless of Microsoft open source, I want to see the hard data. So, now we know why they do that. The question is, does the outcome match user expectation? How can we test it? Well, we took advantage of the fact that they use the same tool for doing code reviews and that they leave comments. In these comments, I can really see what reviewers said about this particular piece of code. So that if they were finding defects, they would say, okay, you should change this piece of code. So what we did was taking a sample of almost 600 of these threads and we manually categorized them according to what we were asking. We did this classification of review comments and we compared this with what they thought the reason for doing code reviews was. And we did a thing called card sorting. This is again another thing we do in qualitative research. We printed all these 600 threads We spread them on a super large table, and then we started clustering them when they were talking about the same topics. And this is, for example, a stack of cards talking about, with comments about non-necessary code. Okay? This was halfway through the card sorting process. And these are the results. So as you see, the main outcome of code review is code improvement. And you knew that. Very well done. While defects, it's only around 14%. Right? This is very different from their expectations. And what is more, if you look at the comments about defects, you really see that they are very low-level, trivial defects. Like, what if this part is used? Any doubt about precedence? Should this be and instead of or? There are both questions, because of course it's nice to be nice when you do code reviews. You don't want to attack people. That's very important for them. On the other hand, they are very, very low-level issues. Not talking about design, nothing. So basically, code review at Microsoft, the expectation do not meet reality. Okay? Now the question is, what is instead the outcome of code review in open source software systems? Okay, for this study I didn't have to go anywhere. I could do that from home, from my office, and I did that in collaboration with a very good PhD student, Mark Speller, who did this study as part of his master's thesis. So we took a sample of 2 open source projects we knew very well. In this case, Romance and Concat, but we've seen very similar results in many other projects. So what we did here, we manually analyzed more than 1,000 code changes that were introduced due to review. What does it mean? This is, for example, a review happening on Garrett. This is the code submitted, and you see that, for example, here, the name of this variable has changed. Here, this comment has been removed, and here, this cursor.close was also removed. Sorry, was added. Okay, so we analyzed more than 1,000 of these changes, and we also classified them to see which kind of changes they were. And we had this classification. So maybe it was a documentation change, it was a visual representation, like with these white spaces, changing notation, so on and so forth, and some also about more functional things. So the green bars, the 3 bars on top, are non-functional changes, meaning changes that affect the code in a way that doesn't change the way in which the code behaves, which is very similar to what Microsoft developers would recommend in comments in their code reviews. While these ones are the functional changes, things that really relate to bugs or to changes in functionalities, important ones. So to make this a bit bigger, basically both in Concat and Romance, the biggest amount of changes triggered by code review are about evolvability, not really so better comments, better variable names, better white spaces, and so on. And much less changes were about functions in the source code. And if you compare this to Microsoft, results are pretty similar. And if you also look at another 2 studies they've done, different researchers completely separated from us, they also found this thing. So basically, the answer to the question, the title of this talk is, what do they have in common? Well, it's the outcome. The motivation for Microsoft developers is finding bugs, but it's not meant this motivation. You know it's for improving the code, but it's really amazing how, given that you have different motivations, the outcome is actually the same, isn't it? So especially after the days of Microsoft, I thought, why is the expectation not really met? And this is basically what my research nowadays is about. I thought really hard why this was happening. And the reason is that if you, who knows this book? I really recommend this book. It's about research done in software engineering that can be useful for practical purposes for real software engineers. It's a very beautiful book. And there is one chapter about code reviewing. And it says, code reviews, they find bugs faster and more effectively than testing or other non-debugging techniques. But when done inefficiently, they can quickly become unproductive. Okay? So apparently, you can do code reviews, you can get very good results. And this is what you read in blog posts and so on. But you have to do that carefully. Okay? And the problem is that to do that carefully, you only have to rely on yourself. Because it's nowadays code review is a fully manual task. If you look at this tool, which is exactly the same as all the other tools, when you receive some code, what happens is that you have yourself to understand what's going on in code review, in the change you're reviewing, and decide whether it's a good or a bad one. Do you have any support? No. It's just you and your time that makes a code review good or bad. So, I asked you what are the challenges of doing code reviews. I would like to see if there are a few that stand out. Okay, so let me read some. What are the challenges? Understanding the way other people think. Finding proper time to do it. You're boring. Keeping it constructive. Sorry?
Increase the font size.
Oh yeah, sure. Like it takes a lot of time, hard to wrap your head around other people's code at times. It's hard to settle the things, be consistent, proud of their code, make it more simple, time consuming, get enough time to do it, ego, so on and so forth. So that I asked this thing also to Microsoft developers, and basically results were pretty similar. But one thing really stood out as the main challenge of doing code reviews. And it's understanding. Understanding the code you receive is the most difficult thing, and it's the thing that requires the most time. We asked them, without letting them know that we were thinking about understanding as a challenge, how much understanding they needed to achieve these goals. And in fact, if you see, finding defects is the activity that requires the highest understanding. And this is why they didn't have so many defects found in code reviews, because it required very high understanding, which means a lot of time. Code improvements, on the other hand, you don't really need to understand the code so deeply. You can always suggest how to make your code more readable, right? And this is something you can easily do with the diff tools you have in code reviews. But understanding, there is no support for that. And so, understanding means that if I wrote something, I generally understand what I wrote. So to triangulate this finding about understanding, we asked, so what happens if you send the code to the owner? Does it take longer to review files that you are not familiar with, the files that you don't know? Yes. Okay, not surprising. Just for being sure we are seeing the right thing. Is there a difference in comments feedback you receive when a reviewer is very familiar with or owner of the files? Yes, definitely. So understanding, knowing what you have to review is the key point. is there a difference in comments, feedback you receive, and this is the kind of difference. People that understand the code they have to review, their comments reflect their deeper understanding, more likely to find subtle defects, feedbacks is more conceptual, better ideas approaches instead of superficial problems. So the main challenge according to Microsoft developers is understanding, but also social challenges are very, very important. And all these things are not supported by convenience tools. So what I'm trying to do with my research is hopefully improve code review tools, and I hope in the next few years you will see some of these in practice in some tools. And to do that, you need the right data and the right tools. So, who knows about software analytics? Oh, someone. Who knows about data science? Okay. So data science is very popular nowadays. The idea is that there is a lot of data that you can collect from different sources and you can analyze this data to get interesting results. Software analytics is basically the same thing, but applied to software engineering data. As a couple of researchers put it, software analytics is analytics on software data empowering software development individuals and teams. Let's make this a bit more clear. That's the typical desk of a software developer, and while she's developing, she's using a lot of tools. And all these tools, the IDE, of course we don't use Visual Studio, the debugger, the versioning system, the issue tracking system, executions, the mailing list, all of these systems, they generate a lot of data. The idea of these of software analytics is to use this data to help software engineering itself. So the idea is you take this data, you do some data mining and software analytics magic, and then you manage to help some of these tasks. An interesting thing is that when you build tools to help these tasks, they also generate more data that you can use. I'm going to be a bit more practical in just a second. The idea is to use the same process for code review, also adding review data. Okay? So what does it mean? What can you do with these kind of things? Let me show you. My research is about data support and code review. So one thing you can do is recommend the right reviewers. Untangle the changes. I'm going to tell you what this is. And for example, telling you where to look at when you have to do a code review in the first instance. So, recommender for reviewers. We've just seen that it's very important that the people that receive your code understand your code. So how do I know which people I should send my code? But if you ask this to Microsoft developers, they tell you, I perfectly know who I should send my code to. And then you run some of these, and then you suggest different people, and they say, that's a good one, I didn't think about it. So, recommended for reviews, the idea is that you take the changes that you want to be reviewed, you add data from the versioning system, for example, about who changed this code first, who reviewed this code, but also from the issue tracking system, who fixed the bug, and so on and so forth. And with this data and data mining, you can easily suggest who should review your code. Isn't this something useful to have, for example, in GitHub when you send a pull request that automatically tells you, okay, these are the best people that should review your code. And maybe if you're in a team, you also want to include some rules yourself, like saying, I always want a junior person to be there, so he or she can learn what code should look like. The second thing is untangling changes. How many times have you seen a commit in which there are multiple tasks being addressed, like bug fixing and refactoring? Like, who saw this more than 50 times? Alright. The idea of this tool that we already developed is that it basically takes the changes that you would like other people to review. It uses data from the versioning system about past changes, but it also records a lot of data while we are developing. We created a plugin in the IDE for this. automatically it splits this change into self-contained changes that should be reviewed in different instances. I don't have time to give you all the details, but you can contact me and I'm very happy to talk about these things. But just to make you realize how much power you have if you analyze the data that developers produce to have code reviews. And finally, developers always don't have much time, so you want them to focus on the things that may be the most recent, right? So that they check these things first, and then if they have a bit more time, they maybe can check the other things. And this you can do. If you analyze the history of past defects, the history of changes of files, you can really pinpoint parts that are very likely to have bugs. And for example, with this we created a plugin in GitHub that lets you also using static analysis tools like FindBugs, PNB, and so on, that lets you look carefully at these files because they are critical. There might be errors. Okay, so these are 3 things you can do, but we have many other things in mind, and I hope this triggers some interest from you about these things. And one thing we're also working on is creating an analytics platform for GitHub, basically a plugin that will record how you use GitHub requests so that we can understand it better and provide better tools. Because it's not about, of course, this data can be anonymized, but the idea is to use data for good uses in these things. Okay, so that's the overall idea, and it's based on the difference between the outcome, the expectation and outcome of code reviews. So this concludes my talk. I would like to summarize it a bit. So the question was, what do code reviews at Microsoft and in open source have in common? Explaining why I think it's important to do research on code reviews. We did an empirical study at Microsoft to see how developers do code reviews there, and we found that expectations do not match reality. And the outcome is exactly the same in open source software systems, even though you knew that the outcome was a different one than Microsoft wrote. And why this happens? Why don't we do deep code reviews? Why do we find shallow things? Because doing code reviews is a very difficult task, and now it's fully manual. The idea is to bring data to have code review. Okay? Before concluding my talk, if you like these topics, I'm looking for 2 PhD students working with me, and if you happen to be a master student, I'm also always looking for great master students to work with to write a great master thesis. Okay? And this concludes my talk. Thank you.
So, thank you very much. Are there further questions? May I know the microphone ask the first person?
Loved your talk. I think you're completely wrong about everything.
This is what I want to hear.
Right. In that case, I would say you're encouraging what I think are the wrong habits based on my review experience, which is close to a decade of really intense reviews. To me, the number 1 goal is to improve clarity of the code, the accessibility. Correctness is secondary. So, in my experience, this bit where you do most of your review work doing superficial things is really just getting the first hurdle out of the way, which is, I don't know this code, I must be able to understand it. And the best reviewers I've had are the ones who were able to say, I'm not an expert in this, make this clearer, more accessible to you. And so, when you select the right reviewer for the code, you're not going to get that feedback from somebody confident enough to do it. When you untangle the code, you permit coders to run large battleships, large chainsaws, but what you really want is for them to come back in for really very, very regularly in small increments. Have I had something?
Okay, so thank you so much for this contrasting point of view. So, you're basically saying that, if I understand correctly, that it's better to have someone who doesn't understand the code to review your code so that you know what you have to improve to make it more readable. I totally agree with you. Definitely. And this is why it's very important when you have a recommender for reviewers that you let people the possibility to put rules, like I want junior people or I want someone who's really not expert. But as long as you don't have data to know who's not expert, how can you know that? This is one point. The second point is, unfortunately, sometimes there is not a lot of time for doing reviews. So, and we have one full static analysis tools that, for example, can do the formatting, white spacing, variable renaming, all for you. So why not using that in the context of code review? And let the reviewers spend a bit more time on the more important parts. So I totally agree with you, and this is an important point. Thank you.
So you said that the code reviews, you said that the code reviews, I mean, you focus on two main things, like improving code style, standards, usability, and everything, and like removing bugs with code reviews. Then there's one thing that's really hard to test, but if you're already doing research into this, I think it would be really fun to look at, is how many bugs are actually avoided because of refactoring the code so it's more usable in the future. Like if you have a lot of copy-pasted code and the reviewer will say, hey, this looks the same on these two levels and you can reuse it and just refactor it so that you put it in a function, and then in the end when someone changes something in there, like the copy-pasted part will be affected as well, and you will avoid bugs in the future because of improving code quality. So the distinction between those two is not as clear-cut as one would think. And my question is, have you looked into this, and would it be possible to have some metrics on how many bugs are avoided due to better code quality that you get from reviews?
Okay, this is very fascinating question. So it's always very difficult to do studies and find the reason why a bug is found. And it's even more difficult to find the reason why a bug is not found. What I'm saying is, it's very hard to say if a practice had with reducing the amount of bugs, especially because there are many factors that lead to bugs. It's very difficult to say. But definitely, I agree with you that code quality also improves, makes bugs less likely. People don't understand the code better, so there will be less bugs. So this is a very interesting study. I will think about how to do this. Thank you.
To go back to the previous point, in our organization for junior developers, we actually do 2 code reviews. One that focuses on correctness and bugs, and then the second one, which is called the readability review, that focuses only on style and clarity. And it's self-selected reviews that care about this sort of thing, and it's been very good, and it does help a lot.
Thank you. So it's very interesting to hear about these different practices. So in the sample we studied at Microsoft, they didn't have this division. They may have someone like a tester or even a project manager to look as a reviewer of the code, just to get the reference sample, but they wouldn't comment or say anything about it. But this is, thank you for sharing.
Yeah. So I'm going to reinforce more as this part, even more than code quality. The main purpose of code review is actually to get the design improved. So that's in some sense much easier in finding bugs. As long as you have experience in the theory, you get immediately to the desired result point.
Yeah.
So that's the point of having subject matter experts, not just people who are with the theory. For finding bugs, there's stuff like static analysis, covariative planning, or whatever. I think finding bugs in code review is important, but overrated.
So I haven't found like any traces of these high-level issues that you are talking about. Like this code should not be this way. It should factor, but completely change the code. I haven't seen that. Probably because they did this kind of design reviews a bit before. But that's another thing. That basically, you don't have any support for the code review tools, and it would be good, for example, thinking about software visualization. If these could have these things.
Please don't talk in on microphone, so we don't get that on video. Thank you.
You talked about how developers think that better code review clients come from people more familiar with code. How do you know any actual number crunching of years' experience in a particular area versus actual code review clients to confirm that, or is that all just subjective?
Could you please repeat your question? I didn't hear it.
You talked about the correlation between more experience in an area of code and better or more conceptual code requirements. Is that based on actual numbers in terms of analysing code requirements, or is it just subjective?
Okay, so this was based on the survey data, but that's something I would really like to test with code review, and this is something that can be done. See the effect of experience of, for example, number of comments that would be very simple. That's a good point, thank you.
Nice presentation. Have you studied some advanced concept like people coding together and then it's like a code review at the same time?
So I'm looking with another researcher from Freie University of Berlin. He's doing research on pair programming, and we are trying to look at the similarities with code review. What really changes is the way in which you share knowledge. But I haven't looked at this point very deeply into that. One thing I want to report here is that at Microsoft, where developers are co-located, 20%, 30% of the time, instead of using the tool, even if they are separated by many offices, they prefer to meet and talk in person. These alleviates problems with the bandwidth, you have to share knowledge, but also if you have to write a harsh review, it's better to say something in person. So these are the things I know about code review in person for the moment.
Okay, one more quick question and answer, and the time is over.
I stopped thinking. Do you have any suggestions, recommendations, how many reviewers should be taken into the review? So when does it make sense to involve all the team in the review, or when does it make sense to pick one expert, one or two experts?
So there have been a few empirical studies looking at what's the sweet spot of the number of reviewers. It seems that 2 to 3 reviewers is the good amount to have a thorough review of it. So you don't want the entire thing. But they haven't studied this in terms of helping with awareness. But normally developers wouldn't have time to review all the changes, all of that. So 2 to 3 seems to be a reasonable number. Does it answer your question?
Okay, thank you very, very much for the talk. It was very interesting. People here also have many questions about that and discussion. It was not only a question, but a discussion. I loved it. And I think you all loved it. So thank you very much.